All right. So today we start the new unit, which is on congruent triangles. Gentlemen, let's go ahead and shut the laptops, please. Thank you. Just wouldn't want you to be distracted by anything else. So when we first talked about the idea of two objects being congruent, we used your hands, right? And we said you can put your hands palm to palm, and they pretty much exactly match up, right? Same size, same shape, okay? What if you match them palm to the back of your hand? Yeah, they don't match up that way, do they? And trying to match them up this way is just uncomfortable. Okay? So if I match them up this way, I've just matched them up wrong. They're still congruent, but they just don't match up this way, right? Palm to palm, everything matches up. My thumbs match, my pinkies match, every piece, same size, same shape, okay? So when we're talking about congruent polygons, like triangles or octagons or hexagons or any of those things, they're congruent if and only if, which is a strong way of saying this is the only way it works. You can match up the vertices so that every pair of corresponding sides and angles are congruent. So with my hands, if, I don't know, I'd been in some tragic accident and the tip of one of my pinkies was missing, would my hands be congruent anymore? No, because one part that matched up weren't the same. With triangles, every part that matches up has to, was that a bad example?
No, it just reminded me of something from work.
Okay, so I had a friend in high school who worked at a barbecue place, and he cut the end of his finger off one day, and he's like, I couldn't find it because it was mixed in with the barbecue. So he's like, yeah.
Yeah, well, one of our employees was moving a huge, like, flat top grill for one of the restaurants that we worked in. And one of our other employees kept telling him, like, don't do that, you're going to cut yourself. And what happened was he cut the tip of his thumb off.
Nice.
So, yeah.
Nice.
I know, right?
All right. So here in this picture, I have two polygons that are congruent to one another. Polygon A, or triangle ABC is congruent to triangle SRT. Notice all of the matching pieces have been marked congruent. Angle A is congruent to angle S. Those are the matching, or we'll call them the corresponding parts. Angle B is congruent to angle R. C is congruent to angle T. And then all the sides have to match too. It can't just be the angles. It's got to be the sides also. So like segment CB is congruent to segment TR. All those things are the corresponding sides and the corresponding angles. So with triangles, there are 6 pair of corresponding parts. 3 pair of corresponding sides, 3 pair of corresponding angles. One thing to note, in this triangle, I can say triangle ABC is congruent to SRT. I cannot say that ABC is congruent to triangle RTS. Now you're like, well, isn't it the same triangle? Well, that would be like saying I can prove my hands congruent by putting them up this way. You got to match the corresponding parts. How do you match the corresponding parts? Well, doesn't vertex A, isn't it supposed to be matched up with S? So if we put A first in this triangle, we put S first in this triangle, because those are the matching pieces. Down here, they're saying that vertex A matches up with vertex R. Does that make any sense? No. You want to match up the corresponding parts. Okay, so when you say triangle ABC is congruent to triangle SRT, you're not just saying that those two triangles are congruent, you're also saying this is how you should match up the corresponding parts. Okay, so here's an example. If polygon LMNP is congruent to polygon EFGH, Identify all pairs of congruent corresponding parts. Well, there are, on this one, since there are 4 vertices, there are 4 pairs of corresponding angles that are congruent and 4 pairs of corresponding sides that are congruent. So we'll start with the easy ones. Let's do the angles. Angle L. What does angle L have to be congruent to? Angle E. Angle M corresponds, it's the second letter, so it corresponds with, oh, don't everyone jump at once, angle F. Angle N corresponds to angle G, which leaves angle P to correspond with H. So it's pretty simple matching on that. Then we can also do that with the segments. For example, segment LM from the first polygon is going to be congruent to EF. Okay, now what sometimes students get in trouble with on this is they go LM and then they skip over to NP. The next side after LM is MN. What segment is MN congruent to? FG. So if I'm working my way around, what would be the next side? NP, yep. Which is going to be congruent to GH. Then what about the last pair? Yeah, just work your way around. P wrap back around to L is congruent to HE. So this definition, like all definitions, works in both directions. If we know that those 2 polygons are congruent, we know all these corresponding parts are congruent. Or, if we knew all these corresponding parts were congruent, we could say that those polygons are congruent. So, if my hands are congruent, I know my pinkies are congruent. If my pinkies and my ring fingers and my middle fingers and my index fingers and my thumb and my palms are all congruent to one another, then I know that my hands are congruent. Okay? Let's move on to page 2. We mentioned this briefly, and you've actually done some problems with this, but I wanted to go over it again. The third angle theorem. It comes from the angles of a triangle. If 2 angles in one triangle are congruent to 2 angles in a second triangle, then the third pair of angles are congruent. So if I have these 2 triangles, triangle JAM and triangle KYR, if angle J is congruent to angle K and angle A is congruent to angle Y, well, since the angles in a triangle always add up to how much? 180. Then angle M has to be congruent to angle R. Okay, we're going to make use of this third angle theorem in just a moment when we do a proof. This next unit, by the way, will be super heavy with proofs. Lots and lots and lots of proofs. So if you like them, that'll be good for you. If you don't, then you may have to work a little harder. Okay? All right. For this problem, given the triangle ABC is congruent to triangle DBC, notice that tells you not only that the 2 triangles are congruent, but it tells you how to match up the pieces. That the angle at A is going to match up with the angle at D in the other triangle, for example. Find the value of X, Y, and the measure of angle DBC. Okay, so let's take a look. We're trying to find X. So it says this angle is 2x minus 16. Well, the angle at C in that triangle, which is triangle DBC, matches up with the angle at C in the other triangle. And how much is the measure of the angle at C in the first triangle? 90. So that means that 2x minus 16 has to be equal to 90. So we'll add 16 to both sides and have 2x is equal to 106. Dividing by 2, we get that x is 53. All right, then for this next one, we're trying to find y. So 6y plus 5, that's segment AB, right? What does AB in this triangle correspond to in the other triangle? DB. And the corresponding parts have to be the same measure if these two triangles are indeed congruent. So that means that 6y plus 5 has to be equal to DB, which I know is 29. So subtract 5 from both sides, and we have 6y is 24. Don't know why I wrote 2y. And then divide by 6, and we get y is equal to 4. And then the last thing they ask is for the measure of angle DBC. Along about this time every year, I have some students who just lose their minds when it comes to naming angles. They're like, DBC, what angle is that? It's the angle that goes from D to B, and then from B to C. It's this angle right here. That's what we're looking for. Remember, when you name an angle by 3 letters, it's like you're tracing it. The middle letter tells you where the vertex of the angle is. Well, the angle at B in that triangle matches up with the angle at B in this triangle. These two are matching angles. Unfortunately, I don't know either of them. But I can find this angle in the first triangle. There are 2 ways to do that. There's the fast way and a little bit slower way. I'll take a volunteer to tell me how I can find the measure of this angle. Yes, sir.
X plus 72.1 equals 90.
Okay, so this angle plus 72.1 has got to be 90. So what would be the fast way to find this then?
90 equals 72.
Just
subtract 72.1.
Yeah, you're just going to do 90 minus 72.1. And let's see. So we're going to have to do a little borrowing here.
17.9. Yes.
Seems like that's about right. So this is 17.9. So this is also 17.9. Okay, any questions about that? All right. Then let's take a look at a proof. So for this one, here's your diagram. We're given that angle A is congruent to angle D. We're given that segment AB is congruent to segment ED. We're given that C is the midpoint of both segment AD and segment BE. And we're asked to prove that the triangles are congruent. In order to know that the triangles are congruent, again, it's just like your hands. All of the matching pieces have to be the same, or they're not congruent. So we need to check, are all the matching pieces congruent? So we'll do a 2-column proof for this. Later this week, I'll show you another kind of way of writing a proof that some of you may like. Some of you probably won't. We must have a college representative coming today. I'm assuming that's what all the noise in the hall is. So all that's given. And I'm going to mark the things that I know are congruent so far. I know that angle A is congruent to angle D. Mark it on the diagram. I know that segment AB is congruent to segment ED. That's what I know so far. So I've got 2 pair of things that are congruent. I need 6. All 3 pairs of angles, all 3 pairs of sides. The given gives you a hint, though. It says C is the midpoint of both segment AD and segment BE. So see if you can draw back on memories from earlier this semester. What does that let me conclude? If C is the midpoint, let's just say C is the midpoint of AD.
B and E are equal.
That means A, C, and CD are equal.
Close. Really close. What would we say about the segments? They are not equal, but congruent, yeah. We would say segment AC is congruent to segment CD. And because C is also the midpoint of BE, what can we say? No. B and E are points.
B, C, and C, E are congruent.
Yeah, BC is congruent to CE. So I know that AC is congruent to CD. Notice I'm marking those with 2, not 1 again. And then the last pair of segments I'll mark with 3. How do I know that? Well, that's the definition of a midpoint. Let's close that, please, sir. Thank you. So now we've got all the matching sides congruent. The definition says, though, all the matching sides have to be congruent and all the matching angles. So far I've got all the matching sides, but I don't have but 1 pair of angles. And there's no more hints in the given. Nicholas has a thought for us.
The midpoint of C creates 2 vertical.
Okay, and what do we know about vertical angles?
Congruent.
They're congruent to each other. Can you name them?
Would be angle C and angle C.
Can't call any angle C in this diagram, because if you say angle C, nobody knows which of those 4 angles you're talking about.
And DCE.
So what was the first one?
BCA
BCA, okay.
and ECD.
Okay. How do we know that's true? Because vertical angles are congruent. Every time he reaches into the bag for candy, I have a vision of you knocking over some third grader and stealing his Halloween candy. I don't know why.
That's like this.
All right. Do we have all three pair of angles congruent yet?
No.
No, we've only got two pair. If only we knew something about the third angle.
Theorem.
We can use the third angle theorem to say what?
If two of the angles are congruent, the third angle is congruent too.
Right. So what's the third pair of angles here?
ABC and DC.
Yeah. Or you can just call it angle B and angle E. Either is fine though. So angle B is congruent to angle E because of the third angle theorem. So are all the matching parts congruent to each other at this point?
Yes.
Yes? So that's enough to know that the triangles are congruent. So triangle ABC, Liam, you with us? Is congruent to triangle DEC by the definition of congruent triangles. And you're welcome to abbreviate like that so you're not having to write out all the words. Because it gets pretty long if you're having to write out all the words. Okay, any questions about that? Yes, sir.
Can we still prove that triangle ABC congruent to triangle DAC without 3 and 4?
We will learn some things about that later on. There are some shortcuts, but for right now, you have to do all 6. But yeah, we're going to learn that there are 1, 2, 3, 4. I guess there are 4 or 5 shortcuts to proving that the triangles are congruent. Okay? All right. Your assignment is in the book. We do have some time left in class, so I expect you to get started on it now, please.